Hello friends, I welcome you in lecture number 10 on higher order partial differential equations. From last lecture onwards, we are discussing shortcut methods for finding particular integral of non-homogeneous higher order partial differential equation. And we have seen that these shortcut methods are applicable for particular functions on the right hand side of differential equation in this form. In earlier lecture, we have seen how to find out particular integral if right hand side function f(x)y is exponential function in the form e raised to ax plus by. In this lecture, we are going to discuss the case that right hand side function is either sine ax plus by or cosine of ax plus by. If we have this special right hand side, then we have another method for finding particular solution or particular integral of this type of non-homogeneous partial differential equation. If you recall, if f(x)y is equal to e raised to ax plus by, then particular integral was given by 1 over f of ab e raised to ax plus by if this f of ab is non-zero. That is, we put d equal to this coefficient of x and d dash equal to coefficient of y, and we check if f of ab is non-zero or not. If f of ab is non-zero, then this is going to be particular integral for this type of right hand side, that is exponential function. Now our right hand side is sine of ax plus by or cosine of ax plus by. So in this case, we will remember that for particular integral, we will replace d square by negative of square of a square, that is coefficient of x. D dash square will be replaced by negative of b square, where b is coefficient of y in sine of ax plus by, and d into d dash will be replaced by negative of this a into b. So this we will remember, and we will proceed further. So we will understand this method with the help of one or two examples. But what we have to remember that if right hand side is in the form sine ax plus by or cosine of ax plus by, then we will remember that d square is to be replaced by negative of a square, d dash square is to be replaced by negative of b square, and d times d dash is replaced by minus a times b in this operator or function of capital D and d dash. So we understand this method with the help of this example. Here we have second order non-homogeneous partial differential equation, and we can see here this we can rewrite as d square z. This is d dash z. Del z by del y is denoted by d dash z and minus z, and we are taking z common, so we have written this left hand side in this form. So here this is our function of d and d dash. Now here we have to solve this differential equation. That means we have to find out its general solution. So first we will find out the solution of homogeneous differential equation corresponding to this given non-homogeneous equation. So for that we consider right hand side equal to 0, and we find out the solution of corresponding homogeneous differential equation. So we write in this way: the corresponding homogeneous partial differential equation is d square minus d times d dash plus d dash minus 1 z equal to 0, and we know how to solve the homogeneous PDE. So for that we concentrate on the function of d and d dash. Here we can see this is non-homogeneous function of d and d dash. So first we have to see whether we can rewrite this as a product of linear factors or not. So here we write this we can denote by function capital F of d and d dash. So we can rewrite again in this way so that we are able to write it as a product of linear factors. So I combine d square and minus 1, and here I can take d dash common, so I will have 1 minus d. This d square minus 1 can be rewritten as the product of d minus 1 and d plus 1. Here I can take negative sign outside, and this I can rewrite as minus d dash times d minus 1. And now I can take d minus 1 common, and here I will be left with d plus 1 minus d dash. So here we are able to write our function of d and d dash as the product of linear factors d minus 1 and d minus d dash plus 1. Now if you recall that if we have this type of linear factor bd minus ad dash minus c, then the part of solution corresponding to this factor is given by e raised to c x divided by b, arbitrary function of by plus ax if this b is non-zero. B means coefficient of d. So here coefficient of d in both the factors is non-zero. So first we write down the part corresponding to d minus 1. We can compare d minus 1 with bd minus ad dash minus c. Corresponding to d minus 1, if we compare, then we have b equal to 1, d dash is absent, so d dash is not present, that means coefficient is 0. And if we compare this with this, we find that c equal to 1. That is, part of solution corresponding to this linear factor is e raised to cx over b, that is c by b, which is 1, and into x, and arbitrary function of by, b is 1, that is y, plus ax, a is 0, that is arbitrary function of y, that we will denote by phi 1. Similarly, we compare this d minus d dash plus 1 with this standard form bd minus ad dash minus c, and we find that b is 1, a is also 1, and c is minus 1 here. So here we have e raised to c by b into x, c by b is minus 1 into x, arbitrary function of by plus ax, b is 1, a is 1, that is e raised to minus x into arbitrary function of y plus x. This we will denote by phi 2. So we can consider addition of these two, and we can write down the general solution of this homogeneous differential equation. And we know that general solution of this homogeneous differential equation is called complementary function of given non-homogeneous equation. So therefore we can write down the complementary function. Complementary function is cf equal to e raised to x times arbitrary function of y plus e raised to minus x times arbitrary function of y plus x. This is just for understanding. It is not necessary to write down all these things. You can directly write if you are able to understand. You can directly write down the complementary function. Here phi 1 and phi 2 are arbitrary functions. Now next step is to find out particular integral. Here particular integral is 1 over function of d dash, and right hand side, which is cosine of x plus 2y here. So here I write cosine of x plus 2y. And let me rewrite what is FDD dash. FDD dash was d square minus dd dash plus d dash minus 1. D square minus dd dash plus d dash minus 1 cosine of x plus 2y. Now if we compare this cosine of x plus 2y, or if we compare this part with ax plus by, we find that a is 1 and b is 2. And we have to replace d square by negative of a square. A square is 1 and negative of a square is minus 1. So d square is replaced by minus a square. A is 1, so d square is replaced by minus 1. Again d into d dash is replaced by minus a into b, that is minus 1 into 2, which is minus 2. So here I write minus 2, and d dash as it is minus 1 cosine of x plus 2y. Remember, we will replace d square by negative of a square, d dash square by negative of b square, d dash by minus a times b, and rest of the things we will keep as it is. So here d dash as it is. Now if we simplify this, this is going to be, let me write one more step, minus 1 negative negative positive plus d dash minus 1 cosine of x plus 2y. And we can see this is 2 and this is minus 2, that is we are left with 1 over d dash only cosine of x plus 2y. Now d dash stands for partial derivative with respect to y, therefore 1 over d dash stands for integral with respect to y considering x as constant. So integral of cosine function is sine function, and x is considered as constant, and we have to divide by coefficient of y, which is 2. So this is the particular integral of given non-homogeneous equation. Therefore particular integral is this. So here you can understand it is very easy. Now we have replaced this d square by minus of a square, that is minus 1. D into d dash is replaced by minus 2, d dash as it is, and we see that all these constants cancel each other, and we are left with 1 over d dash cosine of x plus 2y. And after integrating this with respect to y, we find this as our particular integral. And the next step is to write down the general solution. Therefore general solution is, our function is z, so z equal to complementary function plus particular integral. So what is complementary function? E raised to x times arbitrary function of y, e raised to x times arbitrary function of y, plus we have another function e raised to minus x times arbitrary function of y plus x, e raised to minus x times arbitrary function of y plus x, plus 1 by 2 times sine of x plus 2y. This is the general solution of given non-homogeneous partial differential equation, and here phi 1 and phi 2 are arbitrary functions. So in this way we can easily find out the particular integral of given non-homogeneous equation if right hand side is in the form sine of ax plus by or cosine of ax plus by. All we have to remember is replace d square by minus of a square, d dash square by minus of b square, and d into d dash is to be replaced by minus a times b. So this is all about this session. I hope you like it. Thanks for watching.